be a web administrator and logged into their website using FTP, then what the malware would do is it would upload the compromised credentials to the Gumblar bot master, and that bot master would then automatically log in to the sites that were compromised and place more drive-by downloads on pages on that website, which resulted in additional webmasters accessing those pages, getting infected, getting their keystrokes logged, and getting their passwords, their FTP passwords, sent to the Gumblar botnet. So you could see how this basically created a cycle, and as a result, 80,000 web servers were able to get infected in a fairly short amount of time. So one might argue that, hey, you could choose passwords that are hard to guess or strong, but basically if there's malware on some webmaster's computer, they can keystroke log the password and their website can be used as a malware distribution vehicle. So this is also in the class of something that's not as easily preventable. But one theme that I'll mention is that in addition to prevention, while it's good to do as much prevention as you can, employing as much detection, containment, and recovery techniques as you can is a great way to employ defense in depth. And I'll talk about how that applies to web-based malware as well. So password compromise is another way for websites to get infected with web-based malware. And of course there's traditional infrastructure vulnerabilities. So if you're on a hosting platform and that hosting platform has a web server or an operating system that it's running, and there's a, say, network layer compromise or an OS level compromise, then the bad guy can of course do whatever they want. So that's yet another manner in which websites can be leveraged to become malware distribution vehicles. Make sense? Any questions? Great. Okay, good. So I talked about the term structural vulnerability, and what I thought I would do is offer a definition of what a structural vulnerability is, since it really hasn't been talked about in the field. And so I'll talk about some of the highlights of this definition. The way to think about structural vulnerability and how it's very different from a software implementation vulnerability is it's a weakness in a web page where the web page may be using some third-party component. And if that third-party component gets infected, then so does the entire web page. And so a structural vulnerability is such a weakness. One of the things that we did at, so one thing I should also mention is that, as I mentioned before, if your website has a structural vulnerability, it's not the case that you should start eliminating all the third-party widgets and code and ads that you use, but it's important to mitigate that risk so that if any of the resources that your website relies on gets infected, your website shouldn't get infected. You shouldn't be infecting users. So some examples are third-party JavaScripts, and some of these are very popular, some of these are not, right? So for instance, Google Analytics, if you on your website use Google Analytics, then if the Google Analytics domain, say, ever got compromised, then your website could be turned into a malware distribution vehicle. Now, Google, of course, I should mention, employs a lot of great defenses to make sure that their website and that Google Analytics doesn't get compromised, but there's a lot of different third-party widgets out there, and not every third-party widget company will have the same defenses in place. Another example is jQuery. It's a very commonly used widget, and it can either be hosted directly on your website, you can have the code there, or you could point off to some other website that hosts jQuery for you. In addition, there's a lot of websites that might use widgets like online surveys, where basically you could take part of your website and allow the user to fill out a poll. And of course, if this particular survey widget gets compromised and the bad guys, say, inject a malicious iframe or something else in there, then the website that's serving it turns into a malware drive-by download vehicle. And the attackers like to take advantage of these types of widgets because when they compromise the widget, they compromise lots of websites all at the same time. So those are just some examples. At Dacian, one of the things that we recently did to understand how big this problem can be is we ran a study where we looked at several thousand of the most popular Quantcast sites. Quantcast is a kind of a traffic measurement marketing company that ranks the websites that get the most traffic. So we looked at several thousand Quantcast sites and also looked at a whole bunch of Fortune 500 websites. And what we had found is we had basically run scans of these websites where we weren't looking for the malware itself. We can, of course, do that. But what we were looking for was structural vulnerabilities. We were looking at what third-party widgets, what third-party ads, what third-party applications were they using on the website. And we came up with some interesting results. So one of the things that we had found is that 3/4 of the sites on the internet use some form of third-party JavaScript widget. And of course, that can result in a structural vulnerability for the website. We had also looked at external advertisements, and we found that 82% of publishers run third-party ads on their website. So that was interesting. We also found that on average, a website on the internet has a 41% likelihood of running some kind of third-party ad. In addition, one thing that we thought was interesting is we ran this across different verticals. So of the Quantcast sites and the Fortune 500 sites, we categorized them by vertical and found that financial institutions were just as likely as other websites to run third-party advertising and use third-party ad widget resources of various kinds. And of course, if they become compromised, well, then so does the financial institution's website. So that covers the widgets, that covers the ads. In addition, we looked for third-party applications. You know, was there a content management package like a WordPress or a Joomla or a Drupal running on the site? Was there, a shopping cart? Was there, some other third-party application that wasn't built by the company whose domain runs the website? And we found that over 90% of businesses not only have third-party applications on their website, but they were running an outdated version of that third-party software that may have some vulnerability. And if you think about these things, one thing that's interesting is that this third-party reliance is a natural part of the internet, but the vulnerability that results as the vulnerability that occurs as a result of having these issues is not well mitigated. So typically what we've seen is that when websites get infected, say through a third party, there was in fact a case where there was a Quantcast 100 publisher that was using a very popular traffic management widget that got infected, and very often people find out when customers report it, or when they find it through other folks that report it, but or when a search engine flags the site. And that's not the ideal way to find out about a third party that's getting compromised. Let me talk about a couple more stats around structural vulnerabilities, and then talk about a number of things around how to address these issues and make sure that structural vulnerabilities on your website doesn't result in web-based malware infections. So I mentioned the overall stat that 75% of websites use third-party JavaScript widgets, but there's a couple verticals that rely on third-party JavaScript widgets even in a much more likely way. So consumer packaged goods websites, financial websites, high-tech websites, publisher websites, and travel and entertainment websites had a much higher reliance on third-party JavaScripts than otherwise. There was a number of companies that relied on third-party ads and third-party advertising-related resources. I had mentioned that it was surprising to me that financial institution and financially oriented websites ranked at 41%, which was just about average. And while it may not have been, say, the online banking part of the website, it may have been a part of the website where there's a community where people can share financial advice, for instance, where we'd see some such resources, or the website would be relying on a third-party ad widget to basically manage their own house ads and rotate them, etc. So that's where that came from. In addition, high-tech websites, retail websites, travel websites, and publisher websites had a significant reliance on third-party advertising. And by the way, advertising on the web can be a great thing. It's in fact funded the development of a lot of content and made a lot of business models possible. So I think that eliminating advertising on websites is not also the right way to go. But if there are structural vulnerabilities due to advertising on websites, it's important to just mitigate them. The third category of outdated web application and other software packages, we found that certain verticals here, retail, manufacturing, consumer packaged goods, publisher, and high tech, had a fairly high reliance on third-party packages. I think it's interesting that to note that most websites, use third-party software, and it's the fact that these are outdated shouldn't be super surprising. As we know from the client world, right? It's very hard to keep a lot of client-side machines up to date and patched, but the same exists on the servers, right? In fact, doing server-side patch management is even harder because you have databases, you have a lot of software code that may need to be upgraded or changed when you upgrade a particular application, and so that's a little bit as to why, why these numbers are where they are. So we've talked about structural vulnerabilities, in a lot of depth because it's something that we recently released, but there's pretty much a number of different categories, as I mentioned, of vulnerabilities: software implementation vulnerabilities, structural vulnerabilities, password compromise, etc. So the question is, given all of these types of vulnerabilities, how do we mitigate the problem of web-based malware, and how do we provide the quote-unquote complete lifecycle of malware protection for websites? Well, let me talk a little bit about what I mean by that. If you look at what goes on in the client-side world, when a client-side PC gets infected by a piece of malware, it's not the case that the antivirus package comes up and says, hey, the computer's infected, you have to stop using it, right? That's not what happens. In fact, the client-side antivirus software will attempt to quarantine the malicious code or the malicious files and allow the user to continue using the computer. Unfortunately, if we look at what's going on in the world of the web, when a website gets infected and when a website is serving malware to its users, if we look at what's going on with the way that the search engines and the way that the browsers are currently handling this, the users pretty much cannot use the website anymore once the site is infected, which is to an extent the right thing for the search engines and the browser companies to do. They want to protect users. That is the right thing for them to do. Unfortunately, for the website, it has very negative repercussions sometimes, and it would be nice if we can move to a better model. Move to a model where even if a website does get infected, there be a way that we can provide the complete life cycle, not just the detection, but the containment and the recovery in an automated way as well. And so what I'm going to do is talk a little bit specifically about detection and containment, realizing, of course, that when you deal with any particular security problem, there's a number of different types of defenses that you want to deploy to have defense in depth. You want to be able to assess issues, you want to be able to prevent issues wherever you can, you want to detect, you want to contain, and you want to assure users and customers. But I'm going to focus specifically on detection and containment, and I'll talk about how mod anti-malware can provide the containment to today's world, which doesn't exist today. Make sense? Any quick questions? No? Good. Okay. So this is a hard problem. We need to bring the entire life cycle of protection to the web, and there's a number of kind of sub-problems that we need to address. One of the key problems that we need to address is that whenever a website gets infected, it's important to root cause exactly where the infection is coming from, because it could be due to a whole bunch of different things on that website. And you want to be able to root cause what happened in a targeted way. And if you think about this, this is a little bit different than, say, what a search engine or a browser or an AV provider needs to do, a traditional AV provider, that is. In those cases, they simply need to detect that the web page is infected and put up the appropriate messages. On the other hand, if we want to be able to contain the impact and we want to allow users to be able to continue to use the site, we need to figure out what is the root cause of the problem, what is the widget that's causing the problem, what is the ad that's causing the problem, etc. And identify that and basically strip that out, or basically make